Okay, hello everyone. Now in this class we are going to be discussing array representation of stack. It is also called as a memory representation of a stack. In this we are going to be representing an array as a stack data structure. What is stack? Stack is an order collection of data elements in which insertion of new element and deletion of existing elements are always taken place as same end. That end is called as top. But now what we are doing in this array representation of stack, we are using an array and we are implementing that array as a stack. In array, it is possible to insert an element at anywhere in this array, and it is also possible to delete an element from anywhere in the array. But in stack, it's not like that. In stack, we are having only one end. From that end only we need to be insert an element into stack, and from that end only we need to be delete an element from stack. That called top. From top pointer we need to insert element into stack. From top pointer we need to delete an element from the stack data structure. But we are using array and we are implementing this array as a stack data structure. Then how we are implementing this, how we are representing array as a stack data structure, we are going to be discussed in this class. Now I declared an array integer a of 5 means it is able to store 5 integer elements, means 5 memory locations, 5 consecutive memory locations. If you are using as a simple array, then I can insert anywhere in this array. Usually we start inserting from consecutive location only, but it is possible to delete anywhere from the array. Right? Now what I am doing, I am using this array and implementing this as a stack data structure. Right? If top pointer points to maximum of stack or maximum of this array, then stack is full. It is a overflow condition. We checked this overflow condition in while discussing stack data structure. If a stack pointer is pointing to maximum of a stack, then it is not possible to insert an element into stack data structure. In the same way, we are considering variable top and considering a variable top. If this top pointer pointing to and maximum of stack maximum of stack is nothing but total how many elements I can store? 5 minus 1, that is 4, that is n minus 1. If a top points to 4, then it is not possible to insert an element into stack data structure or this array data structure, that is stack is full, that is overflow condition. The same way, if a top pointer is pointing to null, means which does not point to any point or any index of this array, then stack is empty. That is stack is empty. Now I try to insert an element into stack data structure. I want to insert an element into stack data structure, and what I need to perform is stack of top equal to elements, which is the same how we are inserting an element into stack data structure. Now I want to insert an element into this array. Simple. A of top equal to element. A of top equal to element. Where top is the pointer from which end or from that point we are inserting and deleting an element from this array. If we achieve this, then it is nothing but we represented array as a stack data structure. We represented this array as a stack data structure. Simple. If you want to insert an element into stack data for incrementing top pointer value, simply as the same top equal to top plus 1. It is how we are going to be increasing the top pointer value. Now I want to insert an element into stack. Initially I told top is pointing to a minus 1, top is pointing to minus 1. Now I want to insert an element into this array, that is A of top equal to initially top -1 plus 1 equal to 0. Now top is pointing to 0. If top is pointing to 0, if you want to insert an element a of top value is 0, a of 0 index, you want to insert an element 10, just insert 10. Now you want to insert one more element, increment the top pointer. Now top pointer is pointing to an index 0, just increase to its the next index, that is top equal to top plus 1. Now top is pointing to 0th index, 0 plus 1, 0 plus 1, that is top equal to 1. Now top of first index, insert an element, that is 20, insert an element 20. It is how we are representing array as a stack data structure. Array as a stack data structure. We discussed the representation of stack using array. Now we are discussing array representation, memory representation queue using array. The same concept. If you want to insert an element into queue data structure, we require two different insertion as well as deletion. We require two different pointers. Those are front pointer and rear pointer. Now in this class, what we are discussing, I am representing memory representing queue using array. In array, we are allowed to delete from anywhere, but you are using array as a queue data structure, then we need to be delete from one particular position. How we are doing? Now we are going to discuss with an example. I declare an array integer a of 6 which is able to store 6 different elements. In which I insert the element a, b, c, d. In which I am having a front pointer and rear pointer. Queue contains two different pointers. Those are specifically meant for insertion and deletion. Front is for deletion, rear is for deletion. If a front pointer is pointing to null, it means that queue is empty, it is not possible to delete any element. If rear pointer is pointing to L, then queue is full, it is not possible to insert any element into queue data structure. Now I declared an array, I inserted a certain element. Now I want to use this array as a queue data structure. Then I need to maintain two different pointers, those are front pointer and rear pointer. If I start deleting from elements from this array using front pointer, if you want to insert, if you using rear pointer, you are inserting the element into queue data structure, which means that we implemented this array as a queue data structure. See this example, this code for insertion, just I need to increase the rear pointer, rear equal to rear plus 1. In queue of rear, I need to insert an element. In this example, rear pointer is pointing to an element d, that is index 4. If you want to insert one more element into this queue data structure, what I need to do is simply I need to increase this rear pointer. At increased position, I need to insert an element. That is, now currently rear pointer is pointing to an index 4. 4 plus 1 is 5. Now queue of 5 equal to an element. Now I want to insert an element in. That is, it is pointing to 4th index. If you want to insert, just increase this rear pointer. I increase rear pointer to 5th index, then insert an element. That concept I am using array. I took two different pointers, front pointer and rear pointer. These are the two specific pointers for using deletion and insertion. Simply I incremented the rear pointer, at that position I inserted an element in an array. I am not using queue. In an array, I took a rear pointer and I increased, at increased position I inserted an element. Now I want to delete. If you want to delete, the simple concept. Again, if you want to delete an element from this array, you need to delete an element which is pointing to front pointer. Once you deleted the element from this array, then you need to increase that front pointer to its next higher index value. See this one, deletion operation, element equal to queue of rear. Element equal to queue of rear is nothing but the element which is is pointing to Q of front pointer, that should be deleted. Once you deleted that element, after that we need to increase front pointer. In this, front pointer is pointing to an element A, index 1. Element A, index 1. That is A equal to Q of index 1. Q of index 1, which means that it is going to be, we are removing that particular element from Q data structure. Once we deleted this Q data structure, what I need to do is I need to increase front pointer. That is, initially front pointer is pointing to an index 1. If you deleted an element from this Q data structure, what I need to do is I need to increase this front pointer to index 2. How? Now initially front pointer is pointing to 1, 1 plus 1, 1 plus 1 is 2. Now front pointer is pointing to second index of this array. Second index of this array. I stick on two different pointer variables. Those are front pointer variable and rear pointer variable. In array, I am using two different pointers for performing insertion operation and a deletion operation. If you maintain these two different pointers for specifically for insertion and deletion, which means that we implemented array as a Q data structure. It is how we are representing or a memory representation of Q using array.